Are you big on statistics? The academic discipline? I think I might have asked you this once before.
I haven't studied it in years, but yes.
Because this book that we have in this class, it's doing a terrible job explaining this concept of sampling distribution of the sample mean. Is that something you've contemplated at any time recently? Sampling distribution of the sample mean. I get z-scores, I get the probabilities you can get from them. I just can't seem to get my head around this.
Not ringing a bell.
Well, the good news is the quizzes are due this week. So that's my professor. Just thought I'd pick your brain, possibly. Weird means. Well, not as many as this class.
Happy Wednesday. Half angle, double angle, and reduction. Sine of 2 theta is 2 sine theta cosine theta. Cosine of 2 theta has 3 identities. Cosine squared minus sine squared, 2 cosine squared minus 1, or 1 minus 2 sine squared. And then tangent of 2 theta is 2 tan over 1 minus tan squared. These are the double angle identities. Cosine squared is 1 plus cosine of 2 theta over 2. Sine squared 1 minus cosine of 2 theta over 2.
Two theta?
Yep.
To the power.
Nope. Of 2 theta. Tangent squared is 1 minus cosine of 2 theta over 1 plus cosine of 2 theta. These are the reduction identities. Sine theta over 2 is plus or minus the square root of 1 minus cosine of theta all over 2. Cosine theta over 2 plus or minus the square root of 1 plus cosine theta over 2. Tangent theta over 2 has 3 identities, plus or minus the square root of 1 minus cosine theta over 1 plus cosine theta. Sine theta over 1 plus cosine, or 1 minus cosine over sine. The plus or minus is determined by the location of theta over 2. These are the half angle identities.
What were these last ones? Like
Half angle.
Half angle.
Given the information, we're going to find sine, cosine, and tangent of theta over 2. Sine of theta is 5 over 13, and we know that theta is in quadrant 2. So we know 2 things. Distance from the origin is 13, and the y-coordinate is 5. What does that make the x?
12.
What is it?
It's gonna be, well, negative 12. Well, yeah. The theta, the wrong place. I put it inside the triangle.
That would be theta prime,
Oh, the complement.
the reference.
Oh, okay.
You meant this angle here, right?
Yeah.
Yeah, that's the
I was
reference
just looking
angle.
at my instinct.
Theta being in quadrant 2. What do we know about theta then?
It's obtuse. Zero and pi. Yeah.
Technically, I don't even need the equal. They wouldn't be quadrants, but whatever. Then what can we say about theta over 2?
But it falls in the same range.
Well, I hope theta over 2 doesn't fall in the same range.
Oh, I guess it's gotta be. Wait a second. What can you say about theta over 2? Is between pi over 4 and pi over 2. Just divide everything by 2. Well, wait, you mean theta over 2 in the middle there, right? Yeah.
This means theta's in quadrant 1.
Well, theta over 2 is in quadrant 1.
Meaning theta over 2 is phi. Sine of theta over 2. In quadrant 1, sine is positive. So it'll be positive root 1 minus cosine theta over 2. What is cosine of theta? Now we just have to simplify. Fully simplified, you should get 5 over root 26. Quadrant 1 cosine is also positive. Positive root 1 plus cosine all over 2. One over root 26. Then we don't have sine and cosine of theta over 2. Tangent of theta over 2, you have 3 options. I used 1 minus cosine over sine. Doesn't matter, you'll get the same thing. You'll get 5. Cosine is 3/7, and theta is located in quadrant 4. We know the length of that line segment is 7. And we know the x-coordinate is 3. Y-coordinates. -2√10. We're in quadrant 4. That means we're between 3π/2 and 2π. This means that θ/2 would have to be between 3π/4 and π. Which puts us where?
Second.
In quadrant 2. Sign positive in quadrant 2.
Can I ask you something? Isn't any angle in quadrant 4, if you chop it in half, is going to be in quadrant 2?
Well, that's what we just did here. That's what that says.
Well, I know, I just. Yeah, okay, that's cool. I think you're breaking it down like a fraction for us. It's cool.
Yeah, because you can't just tell. Just because we're in quadrant 4, if you cut it in half, it'd be automatically in quadrant 2. This is why.
Yeah.
So if you're in quadrant 3 and you cut it in half, where are you?
It's gonna be in quadrant 1.
Sure about that?
Oh, shit, never mind, okay. Okay. Now, quadrant 4, though, yeah, okay, I see what you mean, quadrant 3, quadrant 2. Quadrant 3 could end up in any 2 or 1, I guess, yeah. All right.
Right, it'd be between π/2. No,
3π/2 and 0.
it'd be between π/2 and 3π/4, which is quadrant 2.
Okay,
The upper half of quadrant 2.
that's cool.
I actually don't think I needed the y coordinate here.
No, since all these IDs involve cosine, don't they?
Well, tangent you can use sine if you really want to. Do over √14 for sine of θ/2, right? Cosine θ/2. Cosine in quadrant 2 is negative. Negative root 5/7. Tangent of theta over 2, again, you have your choice. If you didn't want to find the y coordinate, you can just use the first one. Which would be negative square root of 1 minus cosine over 1 plus cosine. I mean, we found it, so. Sine would be negative 2 root 10/7, right? Negative 2 over root 10. Before we continue on, Monday we calculated cosine, sine, and tangent of pi over 12 and 5 pi over 12. Right, we did that using the sum and difference identities. I'm gonna do it differently. Pi over 12 is a half of pi over 6. Where is pi over 12 located? So sine will be positive. What's cosine of pi over 6?
Oh, pi over 6. Oh, that's root 3/2. Yeah.
Sine of pi over 12, square root of 2 minus root 3 all over 2. Which looks nothing like what we said it was when we used the difference identity. I believe we got root 6 minus root 2 over 4. which means six. These two values are equal. Right? Sine is a function that means that your input, your pi over 12, cannot map to two different values. Right? Sine of pi over 12 has to equal sine of pi over 12. That means these two have to be equal. Cosine of pi over 12, same thing, right? Just say pi over 12 is a half of pi over 6. Still in quadrant 1, meaning cosine is positive. Square root of 2 plus root 3 over 2. Which is a different form from cosine of pi over 12 we calculated before. Again, that must mean that the two values are identical. Then obviously you should see tangent would be the square root of 2 minus root 3 over the square root of 2 plus root 3. Which of course you can write as a single square root. Funnily enough, I think you get different values or different looks depending on which formula you use. So I do 1 minus cosine over sine. That would be so 1 minus root 3 over 2, which would just be 2 minus root 3 all over 2 divided by 1/2. Right, sine of pi over 6 is a half. That just equals 2 minus root 3.
How did you get from the square root over to just 2 minus root 3 over 2?
Different formula. This one is the 1 minus cosine over sine.
1 minus, what the,
Remember, tangent of theta over 2 has 3 identities. One of them is 1 minus cosine of theta all over sine of theta. So it'd be 1 minus cosine of pi over 6, which we said was 2 minus root 3 all over 2, over sine of pi over 6.
oh, 1 minus cosine theta over sine. Or sine over 1 plus cosine. All right, so. B.
So that is also equal to 1 over 2 plus root 3.
I'm sorry, wait a second. Where did 2 minus root 3 over 2 come from?
That's 1 minus cosine of pi over 6. Right, 1 minus root 3 over 2 is 2 minus root 3 all over 2.
What? 1 minus root 3 over 2?
Common denominator is 2.
Oh, okay. So 1. Wow. Oh, because it's the quantity 2 minus root 3.
Yes.
Oh, that, okay.
That's why I have the 2 written a little bit up.
Yeah, okay. Okay, that was what was throwing me. It looked like just 2 minus root 3 over 2, which didn't make sense. 2.
That has to be root 3 minus 1 over root 3 plus 1. That's what we got when we use the difference identity. 1, 2, 3. All 4 of those values have to be the same. And so there's like a Jeopardy question, right? Could I ask you true or false? Does 2 minus root 3 equal 1 over 2 plus root 3? And the answer is true. We just proved it. That might make a good test question. Except for Caitlin, she gets the hard version because she's an hour late. You'll get the Calc 3 version. And then, of course, 5 pi over 12 You should know what they're gonna be.
Off the cuff.
Yep. Sine of 5 pi over 12 is cosine of pi over 12. Because it's the cofunction identity. Everything just flips in tangent. So I'm not gonna bother doing that. Right, but now you see that depending on which of the identities you use, because pi over 12 you can use two identities for. You can either use the half angle identity or you can use the difference identity. Same answer, but different forms. When you do the homework, be careful. Make sure you actually read the problem. Some of the problems tell you what identity to use. Which is obviously going to change the form of your answer. Express sine of 3 alpha in terms of sine of alpha and cos. All right, so express sine of 3 alpha in terms just of sine alpha, and express cosine of 4 alpha in terms of just cosine of alpha. We can write out 3 alpha as alpha plus 2 alpha, can't we? Then we can use the sum identity on sine, which is what? You don't have it memorized yet? Unacceptable.
I wouldn't wait around for these to get memorized. Looking for sign addition.
What if I threaten to make the final exam closed notes? But you haven't memorized then.
So it's just sine cosine times cosine sine of, the respective angles.
Sine cosine times cosine
Or
sine.
plus, rather.
Ooh, that might be a good punishment for being late. You don't get to use your notes on the test. And I'll still make it the Calc 3 version. That's not good enough. Told us only sine of alpha. Well, cosine of 2 alpha. One minus 2 sine squared, isn't it? Sine of 2 alpha. It's 2 sine cosine. Well, that first part's now in terms of just sine. And now we have cosine squared, which is nice. Because cosine squared is 1 minus sine squared. Sine of 3 alpha can also be written as 3 sine of alpha minus 4 sine cubed of alpha. Again, that's an identity now. So it's one you can use. Cosine of 4 alpha. Cosine of 2 times 2 alpha. We want only cosines. So I'll use the identity 2 cosine squared minus 1. That is still not good enough. We have to get rid of that 2 alpha.
Yeah, I'm sorry, I got to backtrack for a second, so I've just been trying to get all that stuff down, but I've never seen 3 sine alpha minus 4 sine cubed alpha, and you're checking off, we're confirming what exactly?
That's an identity. That's now an identity.
Sine of 3 theta.
Sine of 3 alpha is
Sine
3
of
sine
3
of alpha minus 4 sine cubed of alpha. That is now a proven identity.
So that's a triple angle identity, or triple angle.
If you want to.
All right. Okay. Wow.
Gonna have to use the double angle again for cosine. But remember, that whole thing has to be squared. Oh, wait, that should be cosine squared in there. Yep. Expand out. 2 cosine squared alpha minus 1 all squared. Square of the first term. Plus twice their product. And this will be twice of negative 2 cosine squared. And then square of the second term. Eight cosine to the fourth minus 8 cosine squared plus 1. By the way, that's now a proven identity. And we get to finish up by proving even more identities. I want to prove cosine of 2x is equal to cosine to the fourth minus sine to the fourth. Well, we know that cosine of 2x is cosine squared minus sine squared, right? What are the two things we're always allowed to do in mathematics? We can add 0 and multiply by 1, right? So can I just multiply that by cosine squared plus sine squared?
Wait a minute. Oh, because it equals 1.
Mm-hmm. Cosine squared plus sine squared is 1. So I can just multiply by it whenever I want. But that is cosine to the fourth minus sine to the fourth. So we're done. Notice this had a side effect of proving also that cosine squared minus sine squared is equal to cosine to the fourth minus sine to the fourth.
You look at the top, like an a cubed plus b cubed and factor it with the binomial theorem.
You can. I'm going to start on the other side, but that's perfectly valid.
That would let you factor out the denominator, right? You get like, yeah, but okay, but anyway, but
Yeah, it's gonna, if you go backwards, it's gonna give you the exact same thing. But what you do is you, of course, pick the harder way to impress your friends. Right? You flex your math muscles in front of your friends, or
math of least resistance, man.
you're out trying to pick up a date. You start flexing your math muscles.
Oh, yeah.
And if they're not interested, then they're definitely not the one. So sine 2x is 2 sine x cosine x, right? So half of that would just be sine x cosine x. Bless you. Yeah, you shouldn't hold it back. You can break your ribs doing that.
Such a small, like non-ventilated area.
I mean, in here has the advantage of having no pollen, though. I want to write it sine squared plus cosine squared, not that it matters. But 1 is sine squared plus cosine squared. And we're always allowed to multiply by 1. multiplied by sine x plus cosine x over sine x plus cosine x. And if you recognize this as the factored form of a sum of cubes, then you're done. Otherwise, just go ahead and distribute that out and you'll get the same thing. You get sine cubed plus cosine cubed over sine plus cosine. Cosine x is 1 minus tangent squared of x over 2 divided by 1 plus tangent squared of x over 2. Let's flex our mathematical muscles here. Cosine of x. Can't we use a double angle? Isn't x twice of x over 2? So we can write cosine of x as cosine squared x over 2 minus sine squared of x over 2. I can just divide that by sine squared over x of x over 2 plus cosine squared of x over 2.
Wait, back up a step. I'm sorry. Where did you get from cosine x to equal cosine squared of x over 2?
I use the double angle identity for cosine. The first one.
Cosine of 2 theta.
Right. Cosine squared theta minus sine squared theta, right?
Right.
Isn't x 2 times x over 2?
Sure. Yeah. I mean,
So x is a double angle of x over 2. So theta in that identity would be x over 2. Right, because then x would be twice that.
Okay, so cosine of 2 theta.
Right.
Just write it back.
Oh, wait, I wrote that. Oopsies. I just realized I wrote this backwards. I don't know why I wrote cosine squared minus cosine squared when literally right next to it I had the right order.
Oh, that's of course, because the bottom you've disguised 1.
And again, I just want to rewrite that.
Yeah, that denominator is 1
Yep.
in disguise.
Well, it's not in disguise. It's 1.
I like it that way, though. Think about
I
it.
mean,
Come on, you're
it's
just
1.
Yeah, I know, but it's in very fancy trappings that, you know, but
I mean, it's like saying Batman is Bruce Wayne in disguise, and no, Batman is Bruce Wayne.
but let me have my little memory devices.
So now the question is, which is Bruce Wayne, 1 or cosine squared plus sine squared?
So
I'd say 1, because cosine squared plus sine squared is definitely cooler.
in quotes.
Now divide every single term by cosine squared of x over 2. You're allowed to do that because it's the same as multiplying by cosine squared over cosine squared, which is 1. Cosine squared over cosine squared is 1. Sine squared over cosine squared is tangent squared. And so we now have the identity. Alternatively, what you could have done is just factored out a cosine squared from numerator and denominator. And you would have gotten the same result. 2 times tangent of 2x is equal to that. What would be the obvious starting place? Left-hand side or right-hand side?
Left.
You think the left is the most obvious?
I mean, what, you could do the common denominator, get yourself a cosine squared x minus sine squared x, which is on the denominator, but then you got all kinds of ugliness up top.
You told me the left-hand side is most obvious and then started working with the right-hand side.
No, I was showing why the right-hand side is terrible. I don't want to do that. It looks unpleasant to me.
I'm going to do the left-hand side anyway,
Okay.
but it's actually the least obvious.
Well, if you were gonna do it on the right, you'd have to do common denominator,
Right.
do lots and lots of distribution of the multiplication, get yourself a
Right.
disgusting looking numerator. So I suppose most of it would probably cancel out. Anyway,
It's actually not as bad as you think it is.
I tend to catastrophize.
Yes, thank you, phone. I'm already in class. Tangent sine over cosine. So we get 2 sine 2x over cosine 2x. Sine of 2x though. Two sine cosine. Cosine of 2x. It's cosine squared minus sine squared. For sine of x cosine of x would be 2 sine x cosine x plus 2 sine x cosine x. I added 2 zeros. As my astronomy instructor said, this is what he calls dark voodoo math.
But it all tends to come back to sine squared plus cosine squared equal 1.
It's actually not where I'm going.
Really?
Isn't this a perfect square binomial? Factor a negative out of here.
Well, you forgot the exponent on the cosine, that first quantity. Yeah, and then you factor out -1, get yourself the same.
Factor down negative out of here. That becomes minus. Denominator is the difference of squares, right? That's cosine plus sine times cosine minus sine. And now split your fraction. And there's the identity proven. Sine to the fourth A is 3/8 plus minus a half cosine 2A plus an eighth cosine of 4A. Sine to the fourth, sine squared squared. Good.
If you scroll back here, I think I copied something wrong. Okay, wait a minute. Okay, thank you. Right.
Reduction identity for sine. Sine squared of A is 1 minus cosine 2A all over 2. Do that. Yes. Now square the numerator. 1 minus 2 cosine of 2A plus cosine squared of 2A, right? But this cosine squared of 2a is a reduction identity. One plus cosine of 2a all over 2, or 1/2 plus 1/2 cosine of, I'm sorry, not 2a, 4a. Half plus a half cosine 4a. One plus a half is 3/2, right? And then times a quarter. 3/8. Minus quarter times 2. Is a half. Plus quarter times a half is an eighth. Which is what we wanted.
Once again, I'm feeling like I'm like 2 steps or 5 steps behind everything here. How did cosine squared, all right, cosine squared of 2a turns into 1/2 plus 1/2 cosine 4a.
Yes. Right, it's 1 plus cosine of 4a all over 2. Right, cosine squared theta, 1 plus cosine of 2 theta all over 2. But theta is 2a in that case. These types of manipulations, by the way, are going to be used in calc. All 3 calcs.
Taking Cal 1 and Cal 2. Well, she's taken Cal 1 like at least 5 times and she hasn't passed it once. And then she tried to do Cal 2 last semester.
If she hasn't passed calc 1, why would she even attempt calc 2?
Because her like director or something told her that if she could possibly pass that, she could still move on. And like, I don't.
I'd say she needs to get a new director.
Well, then she also said that she barely done her major and she's been in school for like 7 years, so maybe she should have to proceed.
I don't want to sound mean, but she should probably reevaluate her major.
What major?
I don't really know. Something in like medicine. Probably not medicine. I don't even know. It's not my friend. It's like my friend's friend.
Yeah, she should probably reconsider her major.
But I've been saying, but I'm starting to
I'm
realize.
surprised the director hasn't said something. Normally, after 2 fails, they say something to you.
Where is the trig identity that for cosine squared theta? All I know is 1 minus sine squared.
Cosine squared theta is a reduction identity.
Oh, that one. Oh.
I just did that earlier.
Reduction.
Ugh. Yingling. Sam Adams.
You like IPAs?
Yeah.
Drink Yingling, what makes you think you like something?
Yeah, Yingling is good. I like Yinglings.
Latest lottery.
Sam Adams is really good. Oktoberfest.
Mm,
A lot of boys like to drink those.
Actually, not as much of a beer person. More of a liquor.
Scotch, like whiskey.
Scotch, whiskey. Never had cognac.
really.
Brandy,
Brandy, I like.
rum, my absolute favorite.
Go-to Scotch.
Dry.
Pure Irish coffee. That's how I got through grad school.
Good.
None of that shot of whiskey, none of that shot of Irish Scotch and a cup of coffee crap. No, it's the other way around. Shot of espresso and a cup of Irish Scotch. Warms you up and wakes you up all at the same time. My go-to for grad school.
My problem is I'm allergic to beer. You get that?
That sucks.
All those penny pitchers in college that my roommates were.
That sucks.
Yeah, that's
Well,
No, it's not gluten.
it's the ingredient. It's one of the ingredients
It's
of beer.
something to do with hops, I think, but
Which means
luckily there's,
you have to watch out with some liquors as well.
yeah, but it's, yeah.
Alternatives? Like some type of alternative beers, do they have?
But then it's no longer beer.
non-alcoholic.
Don't ask me about Zima.
I love that when they, oh, you want some non-alcoholic beer?
Yeah.
Bitch, that ain't beer. Hurts me every time I take my wife out. She always goes like, I want a virgin pina colada. And she goes, not a pina colada. Of course, I also pull the dick card and I go, why are you ordering a virgin when you're not a virgin? I don't say that. We have 2 kids. I'm pretty sure everyone knows. Kind of hard to pass yourself off as a virgin with 2 kids.
Nice.
If I'm gonna rate,
A lot of women do that so they don't ruin their bodies.
if I'm gonna suffer through raising a kid, I'm gonna have the fun of producing the kid first. So that was what, 4 identities? Some difference. 5 identities, some difference. Double angle, half angle, reduction. Yep. 5. Technically, sum and difference are two different ones. We typically write them as 1, but they're technically 2 of them, so.
They're to use.
I'll say you're a lot nicer than me. I would be like, it's $1 million.
Dude, every second is gonna cost you $1 trillion.
I'm done.
Damn, that's more than I charge.
Yeah.
We have 2 identities left. Sum to product and product to sum. Right, and then we have to do the best part. Forgot about that almost. Once we do the sum to product, product to sum, we get to solve equations involving trig. Here's the beautiful thing about math. It doesn't care.
It's actually, and I like how our class like tiny now. We had like a million kids and they all were just like, nope. Nope.
Actually, apparently they had a problem with students not paying.
Really?
About half of them left.
It's probably why they were kicked out.
Yeah.
We got an email about that.
Like the first day, like there was barely
packed.
there was barely enough seat.
I just feel like we're all, you ever seen that video of the airplane with the bird on the wing, and as it starts to take off, the bird just slides off the back?
Yeah,
I think we're all in various stages of,
of the bird,
yeah.
of being a bird.
The speed is increasing.
He's the plain flag.
We're losing our foothold.
Because once you get a hang, once you get the hang of trig, it's actually really easy. Oh, I could do this all day, every day. Love trig.
Love your job.
Love trig. Well, I look at it this way. I spent a decade in school suffering on that side. So now I'm on this side.
Yeah.
So I'm just paying it forward. Now I'm the one watching you cry instead of being the one watched cry.
We'll see my tears in here, just.
Right, I know. That's
Oh, you got.
only in the shower.
I was actually in my library the other day screaming, I'm not God, I can't do this, like, I'm not
Yeah,
God.
that one homework took me out.
That one homework about like the graphs and the circle.
Nah, that's physics. Physics is when you cry.
All I know is,
That got me in tears.
But yeah, I kept retaking that problem set.
Yeah, I got me in tears.
So much.
Yeah, no, that was such a. I usually didn't do that.
Maybe it's like too late.
It was like it was like late, I'm using the late kind of scale of 50 in my eye.
You can't,
Great job.
I know.
This quiz should be easy. I have to write up a Harvard version for her.
See, it's fine. Why would you focus yourself more? Word, okay, just.
I hope so. More work for me. We can write up your finals.
Do we get a reattempt sometime?
Nope. Because after finals, I have 2 days to get grades in.
And you're gonna have to pick up your pace a little there, Professor.
Yeah, and what day is the final?